In this next video, we're going to be talking about organic compounds that have functional groups. So a functional group is a particular arrangement of a few atoms that gives a characteristic property to an organic molecule. A lot of organic compounds are composed of one or more functional groups that are attached to a hydrocarbon group, and they give them unique properties. Functional groups can all be found on table R. So this is what table R looks like. So they have all the different classes of functional groups that are possible on the left. In the next column, we have a structural representation of what that functional group looks like and how it would be attached to the hydrocarbon chain. Next, we have a column showing the general formula. This is a shorthand way of showing the structure of these organic compounds. So you'll see a letter R typically here. These R's represent hydrocarbon chains. So it just means some unknown number of hydrocarbons, carbons bonded to hydrogens all around, going off in the direction of the R. So like for this one example here, I have an R going to the left and an R going to the right. That just means there's hydrocarbons going left and right. And this one here just means there's hydrocarbons on the left, and then on the end there's an OH. And in the last column, they give you an example of each kind of organic compound. So they have a condensed structural formula for each, and they have a name. So these are often useful in learning kind of the rules for how to name these things and applying them to the types of questions they're asking you. So our first functional group we're going to talk about are alcohols. So alcohols are when you have one or more hydrogens of a hydrocarbon being replaced by an OH group. So there's three different categories of alcohols. The first one is called a primary alcohol. A primary alcohol contains the functional group CH2OH. That just means there's an OH group that's attached to a carbon that's attached to one other carbon. So it's often written like this, so R-OH. This is what it would look like structurally. And like I said, the definition is specifically that the OH group is attached to a carbon that is directly attached to one other carbon only. So the way you name an alcohol is to replace the final E on the name, where it would have if this was an alkane, but because of the OH functional group, it's no longer an alkane, so you drop the E and add the suffix -al. So this molecule here on the left, this is the simplest kind of primary alcohol that we can have. So we would give it the prefix meth because we only have one carbon. It is not methane because methane would be CH4. Instead of one of the H's on the right here, it has been replaced with an OH group. So you drop the E and you add -al. So this is methanol. Next, I have a compound that is CH3CH2OH. So I have two carbons in my longest carbon-carbon chain, so my prefix is F. And if this was an alkane, it would be ethane, but I can see that it's not an alkane. There's an O instead of a hydrogen here, so I'll drop the E from ethane and add the -al. So this is ethanol or ethyl alcohol. This is the type of alcohol that's in alcoholic beverages like beer and wine. Okay, you also need to be able to draw alcohols from the name. So I have the alcohol here, 1-butanol. So the but tells me there are 4 carbons in a row. So I'll first start with my carbons. The -al tells me this is an alcohol, so it has the functional group OH. And the 1 tells me it's on the first carbon. So I can number left to right or right to left. I'm putting mine on the right. So this would be the first carbon, counting from right to left, but you could have easily had it going on the leftmost carbon here, and it would be the same molecule. So there's my 1-butanol, and my last step would be to just fill in all of the hydrogens to make each carbon happy. So there is 1-butanol. Okay, our next category of alcohols is secondary alcohols. So they still contain the functional group OH, but this time the OH group is attached to a carbon that is directly attached to 2 other carbons. You name them the same way, but you have to give a number to the functional group, just like we did on that last one butanol example. Okay, so here's my structural diagram for my secondary alcohol. So in naming it, we look at the number of carbon atoms. There are 3. So according to table P, that would give us the prefix prop. And the ending is all, enol, because it's an alcohol. I know that because I have the alcohol functional group attached. And it is on the second carbon, so I need to give it a number for its position. So this would be 2-propanol. So as you can see, it's a secondary carbon because this OH group is attached to a carbon, and this carbon is attached to 2 other carbons. So on either side, it's attached to another carbon, which is why we call it a secondary alcohol. Next, I have 4 carbons in a row, so I'll name this, I'll give this the prefix but. And it's an alcohol because I have the alcohol functional group, so it would be a butanol, and I need to give this functional group a number position. So remember, we number left to right or right to left, whichever will give our functional group the smallest possible number. In that case, that would be numbering from the right. So this is my first carbon, this is my second carbon, so 2-butanol. Next, let's try to draw 3-pentanol. So if I have the prefix pent, that means I have 5 carbons in a row. So 1, 2, 3, 4, 5. The enol tells me it's an alcohol, and the 3 tells me that alcohol functional group of OH is on the 3rd carbon. So I can number left to right or right to left. It doesn't matter. This is my 3rd carbon. So I'll put an OH group there, and then I'll fill in the rest of the hydrogens to make them happy, make the carbons happy. Next, we have tertiary alcohols. Again, it's an alcohol, so it contains the functional group OH. And the OH group is, and a tertiary alcohol is attached to a carbon that is directly attached to 3 other carbons. So again, you name them the same way, but you have to give a number to the functional group on the side chain. And in tertiary alcohols, they're also going to have a side chain and a functional group. So you have to give numbers to both of them. So here's my tertiary alcohol. You can see it's an alcohol because it has the OH functional group, and it's attached to a carbon that's attached to 1, 2, 3 other carbons, which is why it's a tertiary alcohol. So my longest carbon-carbon chain is 3 in a row. So I will give it the prefix prop. It's an alcohol because of this OH functional group, so it's a propanol. And it is on the 2nd carbon, so this is a 2-propanol, but I need to pay attention to this side chain here. I need to give this a name and a number position as well. So this is a methyl group because it's CH3, and it is also on the 2nd carbon. So this is 2-methyl 2-propanol. So let's try to draw a tertiary alcohol. Let's draw 3-ethyl 3-octanol. So the prefix oct means I have 8 carbons in a row. So there is my 8 carbons. And it is 3-octanol, which means my alcohol functional group is on the 3rd carbon. So I'll count from the left, 1, 2, 3. Oh no, first we're going to draw the functional group. So not the functional group, the side chain. So my side chain is on the 3rd carbon, and it's an ethyl. So an ethyl group contains 2 carbons. So there is a 2-carbon big alkyl radical. So I'll fill in the hydrogens. So it's CH2CH3. That is my ethyl group on the 3rd carbon. And I also have an alcohol on the 3rd carbon as well. So I will put the OH functional group there. And then the last step is to fill in all of your hydrogens on each carbon to make their octets happy. So there is 3-ethyl 3-octanol. Our next category is organic acids. So they contain the functional group COOH. So it can be written like this. So R stands for a hydrocarbon chain going to the left, and then at the end of the molecule there's a COOH functional group. Now structurally it looks like this. The first O is double bonded, and the second is bonded to the hydrogen. So there's my COOH. So to name an organic acid, you replace the final E on the name if it was to be a alkane with the suffix oic, and then you add the word acid. So here is an organic acid. We have 2 carbons in our carbon chain, so it's going to get the prefix F. And if it was just CH3CH3, it would be ethane. But it's not. I have a functional group here. I have an organic acid functional group. So I drop the E and I add the new suffix oic and then the word acid. So this is ethanoic acid. Next, I have an organic acid with 3 carbons. So it will get the prefix prop, and the ending is anoic. So this is propanoic acid. Okay, let's try to draw butanoic acid. So if it's but, it means there's 1, 2, 3, 4 carbons in my longest carbon-carbon chain. If it has the suffix oic acid, that tells me I need an organic acid functional group. So that is a double bond O and then a single bond OH. And then the last step is to fill in all of your hydrogen. So there is butanoic acid. Our next category is aldehydes, and they contain the functional group COH. So this is what it would look like structurally. The O is double bonded to the C, and then we have a single bond H. So you can draw it 2 ways. So this is one way showing the probably more correct angles in 2 dimensions. This is another way, perfectly correct way to draw it as well in 2 dimensions. So you may see these interchangeably. Don't get confused. It's still the same thing. COH or C double bond O single bond H for both of these. So to name an aldehyde, all you do is replace the final E on its name it would have if it was an alkane with the suffix al. So al for aldehyde. So here's an aldehyde. I have 3 carbons, so I'll give it the prefix prop, and it is not propane. It has the aldehyde functional group, so I drop the E and I call it propanal. Okay, this is a aldehyde as well. It's just drawn backwards, so you need to be able to recognize these things in 3 dimensions. So typically the aldehyde's at the right hand side of the molecule, but you could easily see this as well. So you still need to recognize this as a C double bond O single bond H. This is a functional group for an aldehyde. So to name it, we just give it the prefix for the number of carbons atoms it has, which is 2, so F, and it is ethanal. Okay, we also need to be able to go in the opposite direction. So if I give you the name, you should be able to draw an aldehyde. So butanal will have 4 carbons in a row because it has that prefix but. So there's my 4 carbons. If it's an aldehyde, I'll recognize that from the ending al, and I can use table R to remind myself that an aldehyde functional group is double bond O, single bond H, and then you fill in all the rest of the H's to make the octets on the carbons happy. Our next category are ketones. So ketones contain the functional group single bond C, double bond O, single bond. So this is what it would look like structurally. So the R stands for hydrocarbons going to the left, the R prime stands for hydrocarbons going to the right, and somewhere in the middle of the molecule, either pointing up, like in my picture here, or pointing down, is a double bond O. So the way you name a ketone is to change the final E to -one, and you need to give a number position to the double bond O if possible. Okay, so here's my first example. I have 3 carbons in a row, so I'll give it the prefix prop. It is a ketone because I have a double bond O. So this is not propane, thanks to this functional group here. This is a ketone, so I drop the E and add -one, propanone. Now notice I didn't give it a number, because if I put this double bond O instead on the second carbon, say I put it on the first carbon, it would no longer be a ketone. It would be an aldehyde because it would be C double bond O, and I would only have one more room. I'd only have enough room in the octet here for a single bond H. So that's why I didn't give it a number here. There's no other type of propanone other than 2-propanone. So there's no reason to give it a 2-propanone. Okay, how about this one here? I have 1, 2, 3, 4, 5 carbons in a row, so I'll use the prefix pent, and it is a ketone, so the ending is, I drop the E and add an "-one", and then I need to give a number to this double bond O. Now, I couldn't have had it on the ones, but it could be on the 2. This is my second carbon. If I had it over here, this would also be considered the second carbon, but I could have put it in the middle, and then it would be in the third carbon. So this would be 2-pentanone as opposed to 3-pentanone. Okay, let's try to draw 3-heptanone. So hept means 7. So I have 1, 2, 3, 4, 5, 6, 7 carbons in a row. The 3 tells me the position of my double bond is on the third carbon, so I will count that as my third from the left. 1, 2, 3. So there's my double bond O. And then lastly, we'll fill in the rest of the hydrogens to satisfy all of the carbon's octets. So there's 3-heptanone. Next, we have ethers. So ethers contain the functional group single bond O single bond. So this is what they would look like structurally. So R stands for hydrocarbons to the left. Then I have a single bond O single bond somewhere in the middle of the molecule. And then R prime means hydrocarbons going to the right. So to name an ether, you just name the alkyl radicals that are attached to either side of this oxygen in alphabetical order, followed by the word ether. These are kind of different to name. Let me show you an example. Oh, also, you may need to use the prefix di if you have 2 of the same alkyl radical. I'll show you one of those in the examples as well. Okay. So here's my ether. I know it's an ether because I can recognize the single bond O single bond in the middle of the molecule. So I have an alkyl radical on the left and I have an alkyl radical on the right. So we need to name them in alphabetical order. So this is a CH3, so that's a methyl group. And this is a CH2CH3, that is an ethyl group. So ethyl will come first in alphabetical order, so ethyl. And then I name this alkyl radical, that's methyl. And then the whole thing is an ether thanks to this functional group in the middle here. So I add the word ether. This is ethyl, methyl, ether. Next, let's draw diethyl ether. So if it's an ether, I like to start with the functional group of single bond O single bond. The diethyl tells me the alkyl radicals attached to either sides are both ethyl groups. So an ethyl group would have 2 carbons. So it'll be CH2, CH3 to the left, and then another CH2, CH3 to the right. There's my diethyl ether. Next, we have esters. Esters contain the functional group single bond C, double bond O, single bond O, single bond. So this is what it would look like structurally. This is typically one of the more complicated looking ones. We have hydrocarbons going to the left. Somewhere in the middle of the molecule, you will notice this. Single bond C, double bond O, single bond O, single bond, and then you can have some unknown number of hydrocarbons going to the right. So esters are made from an alcohol and an acid. They're also aromatic, which means they have smells. They smell actually quite nice. So esters are where we get all of our artificial smells and flavors from, for things like perfume and candy and things like that, and artificial flavoring in like seltzers that taste like lemon. It's not because there's actual lemon in them. There is lemon esters in them. So the way you name an ester is you need to identify the part that came from the alcohol and name it as an alkyl radical, and then identify the parent chain that came from the acid and name it but change the final E to an OH. These can be some of the more complicated ones to name, so let's do some practice. So here is my ester. You can usually tell an ester because they're usually one of the bigger ones they ask you to do. And you can always use table R to recognize the functional group. And right here in the middle of the molecule, I have this functional group for the ester. So this is the part, the part that's single bonded to the oxygen is always the part that came from the alcohol. So this is just a single carbon alkyl radical, so it is a methyl group. And then I need to look at the carbon chain on the left here. There's 3 carbons, so I'll use the prefix prop, and I'll drop the E from its name instead of propane and add the suffix -ate. So this is methyl propanoate. Next, let's draw ethyl butanoate. So the functional group, I like to start with the functional group first. So single bond C, double bond O, single bond O, single bond. The ethyl group is my alkyl radical attached to my single bond O. So ethyl means 2 carbons. So there's my CH2, CH3. And then on the left, I need butanoate. So I need 4 carbons in my longest chain. And I'm going to include the carbon that's in the functional group. So 1, 2, 3, 4. And then fill in the rest of your hydrogens. Okay, next we have amines. These are derivatives of ammonia, which is NH3, in which the hydrogen atoms are replaced with organic radicals. So they contain the functional group R single bond NH2. So it would look like this. So I have a functional group, or rather I have a hydrocarbon chain going to the left, single bond N, and then single bond R prime, or this R double prime here. They can be hydrocarbons going in every which directions, or of course they could also be hydrogen atoms as well. So to name an amine, we write the prefix for the alkyl radical and then the word amine. So this would be the simplest type of amine here. I have 1 carbon, so this would be methyl group here, CH3, and then it's just attached to an NH2, which is a amine functional group. So I would just add the word amine, methylamine. Okay, let's try to name this one here. So I have 2 methyl groups attached to my nitrogen here, so I need a di, and then the name methyl because they're both CH3s, and then it's an amine because of the nitrogen here, so dimethylamine. Next we have an amide. These are derivatives of organic acids where the OH group has been replaced by an amine or possibly ammonia. So their functional groups look like this, and structurally they would look like this. So here's the part that came from the organic acid. This is where you'd have the C double bond O and then usually OH, but we've replaced the OH with an amine. So to name an amide, you replace the suffix oic with amide. So this would have the prefix F for 2 carbon atoms, and then you just add the word amide. So this is ethanamide. Okay, let's try to draw propanamide. So prop means there are 3 carbons in our longest chain, and it's going to have the double bond O like an organic acid would, but then the OH group is replaced with an amide, or with an amine group. So this would be NH2. And then lastly, we'll fill in the rest of the hydrogens to make each carbon happy with 8 electrons. Okay, so in summary here, functional groups are atoms, usually oxygens or nitrogens, that are connected to a hydrocarbon chain that give the molecule new properties and a new name. So you need to be able to classify, name, and draw organic compounds based on their functional groups. So functional groups and their general formula, an example of what they look like, and how they're named can all be found on Table R. So this takes a lot of the difficulty off of your shoulders here. So if you know that you're dealing with a functional group in a question, you can always turn to Table R to reference, to look up things of how they would look to draw, or an example of how you would name them, and then just apply those naming rules to the question you're looking at. Obviously, this looks pretty complicated, and it can be quite complicated, but we will study this in class, and we'll do a lot of practice. It's just good that you have some of these notes down already, so that in class we can just get right into drawing and practice naming and drawing these things.